All right, let's look at our unit 1.60, the substitution method, where we talk about trig functions. Now, just to remind everybody, the rules for substitution method. The first thing you want to do is see if you have any parentheses, okay? So the first thing is to get rid of the inside of parentheses. That's the first thing you want to look for. If you have a fraction, say, or fractions, what we want to do is get rid of the entire denominator. Unless there is a fraction, there is a parenthesis. Okay. For exponents, we get rid of the entire exponent. The only thing that can mess with any of these rules is if you have trig. Trig is such a pain. And it's not that it's a pain, but remember our first step in all of this is to take a derivative. So the derivative of trig, because of chain rule and because of all those issues, depending on your situation, these three rules that we have already talked about may not work for us. So trig can cause these rules to change because it's not that these rules are set in stone. These rules you will not find in a textbook. This is what I've learned over decades of doing substitution method. These are more guidelines than actual firm rules. And that's why when you look up substitution method in a textbook, they don't have any rules. They don't have any of these rules because to them, they actually call it trial and error. You're supposed to just guess over and over again until you get the problem right. So over the years, I came up with a step-by-step approach to try to get to the right answer without the frustration of guessing and trying and guessing and trying over and over again. So the only thing that can really mess these up is trig. So let's look at our two trig rules. If you have multiple trig functions, so cosine and sine, you are going to get rid of one of those trig functions, the entire trig function itself. Now, my typical rule of thumb is if a trig function is kind of sitting off by itself, leave alone. This cosine is just there. It's not really doing anything. This right here, we get rid of. Okay, because that's being raised to a second power, that's being messed up on. That right there is causing me a lot of headache, more so than the cosine that's just hanging out by itself. If I look at this over here, it's the exact same situation that we had before, but I removed the cosine completely. So in this situation, we have one trig function. If you have one trig function, you are just going to use the inside of the trig function, and that is it. No more, no less. So let's work through these. So right here, I have two trig functions. So anytime you have more than one, you are going to get rid of one entire trig function. So I'm going to get rid of this one right here. So u is equal to sine of 2x minus 7. And then I'm going to take the derivative. Remember that the derivative of sine is cosine. 2x minus 7. Remember that you have to multiply by the derivative of the inside. That's what makes trig functions so difficult. Okay? And then I'm going to go 1 over the derivative. du is equal to dx. So I found all 3 of my pieces. Boom. All right. Now I can go over here and plug them in. So I have the integral of cosine 2x minus 7. Sine is now gone. And so that's going to be u squared times 1 over 2 cosine 2x minus 7. All right. Anything that does not contain a u can come out front. And because the insides match, those cosines will go away. If the insides do not match, then substitution method will fail because those x's will not go away, and I will have to do integration by parts, or trig integrals, or trig integration, trig substitution. I'll have to try something else. But thankfully these cancel out, and I am left with 1/2 times the integral of u squared du. Okay, so that's just going to be power rule. So I'm going to increase the exponent by 1 and divide by my new exponent. Now is a good time to put in my plus c, and all I have to do now is put back in my sine. If you want to, you can write it in the shorthand notation, and that is to put the exponent right above the sign itself instead of at the end. So either one of these is correct. All right. Any questions about that one? Any questions at all? Now, if we get rid of that cosine and drop this down to just one trig function, then what we are going to want to get rid of is just the inside part. So if you have just one trig function, all you're going to do is get rid of the inside portion. Okay. Now what that's going to do is it's going to simplify this enough that you can use the integral table that I gave you guys in class to get to the correct answer. Okay. So now that I've got this, I can go up to here, plug that in. So that's going to be the integral of sine u squared du. So if you look at the integral table, let me go over here. Where do I want to put this? Let's put it right here. Number 31 on integral table. The integral of sine squared x dx is equal to x over 2 minus sine of 2x over 4 and plus c. Let me double check that that's a minus, so let's pull that up. Come on. And so I'm looking for my Dropbox account. We're not looking in that, we are looking here. And let's see here. Yes, it is minus. All right, so we are good to go. Let's go back. Okay, so in our case, the x is just going to be the u. Now I do want to remember, and this is something I just forgot, there is a 1/2 in front of that du. So I definitely want to remember that. So it's going to be 1/2 times u over 2 minus sine of 2u over 4 plus c. And then all I have to do is plug my u back in and distribute my 1/2. So that's going to be 2x minus 7 over 4 minus sine of 2 times that, so that's going to be 4x minus 14 over 8 plus c. And there we go. I have my answer. All right, now let's look at this one. This is one that we've already worked in the previous lesson, 1.6c, but let's talk about it again. It's got 2 trig functions. This cosine is just hanging out by itself, so I'm going to leave it alone. This sine right here is the exponent. It needs to go. I need to get that simplified down. Okay, so that'll give me u is equal to sine 3x. So now I can take the derivative of that, and that's going to be cosine 3x. And then I multiply by the derivative. And then move that on the bottom. 3 cosine 3x is what's on the bottom. That is under the 1. Du equals dx. And so now I can come up here and plug everything in. All right. Pull everything that is not got a u out front so that I can simplify it down. And I'm good to go. The cosines will cancel out, so that's going to be 1/3. The integral of e to the 1u is 1 over 1 e to the 1u plus c. Plug everything back in, and I get an answer of 1/3 e sine 3x plus c. And here is my final answer. Now, do keep in mind that all we've been doing so far is finding the antiderivative. When you stick a plus c at the end of that, you are finding the antiderivative. And because it's a plus c and you do not know what any of those things are, you technically have an unfinished solution. That is really going to be what is called a general solution. It is not finished. It's not ready to go in production. It is just a basic template. And then we will have to finish that later with the information that we've been given to meet the actual specific issue that we have. All right, so let's do one more. Now, once again, even though this is a fraction, it's trig, so we have to follow the trig functions. This right here, the rule for this, since it's only one trig function, is we're going to get rid of the inside. Normally, we would get rid of the entire bottom of the fraction, but it's got a trig function. So u is equal to 5x plus 11. I'm going to take the derivative of that, and that'll be a 5. And that is going to be 1/5 du equals dx. And we are good to go on that. I plug everything in. And so that is 7 over sine of u du. Okay, I think there's left off. I keep leaving off the fraction in front. 1/5 du. Okay, so let's move everything out front. So that is 7/5 times the integral of 1 over sine u. All right, du. Okay, so there's a couple things going on to finish out this problem. The first thing is that there is no way to take the integral of 1 over a trig function. So what we have to do is we have to deal with that. So the first thing to keep in mind is that 1 over sine is actually equal to cosecant. Okay? Now, that being said, 1 over cosecant is equal to sine. Okay? 1 over cosine is equal to secant. 1 over secant is equal to cosine. 1 over tangent is equal to cotangent. And 1 over cotangent is equal to tangent. So when you're dealing with trig functions, there is no reason to ever have a fraction, ever. You can always convert that over. So this right here is going to be 7/5 times the integral of cosecant of u du. Okay, so let's go back to that integral table that I was looking at earlier. And that is, I think, number 8 right here. So right here, we have the integral for cosecant. Negative ln cosecant plus cotangent. Okay. So number 8 on the integral table. So let's go over here and write that down. All right, was that minus or plus? I think it was plus. It was plus. Okay. All right. Okay. So let's go to here and plug that in. So that's going to be negative 7/5 ln of cosecant of u plus cotangent of u plus c. And u is equal to 5x plus 11. And we will have this problem done. Boom. And there we go. All right. So that finishes up these. And that finishes up substitution method. Now, substitution method does not always work. And the last thing that we have to talk about in this first unit will be integration by parts. So that's going to be the next lesson, and that'll finish up the first unit. I'll save the trig substitution and the trig integration for unit 2. So that is something to look forward to. All right, so go ahead, get started on the homework, and let me know if you have any questions.